Hello. So today we are appearing for Atcoder Beginner 419, and let's see how it goes. This is my second contest at Atcoder, so yeah, pretty excited for this one. Okay, so what is the first problem? Mirage, he knows red, blue, and green in English, respectively, corresponding to SSFFM. And for this, he knows no other words. You're given a string consisting of lowercase. If S equals an English word, that continuous corresponding uh, output at course. Okay. So if it is red, then triple S at coda unknown. Okay. I think I got it. So basically, you will have three words: red, green, or whatever it was. Um, it was red, blue, green. Okay. So I would say a string S, CNS, right? If right, if S is equal to red, then see out what it was. It is FSS, right? So you go with this, and then I will just have this. Else if red, blue, green, right? Red, blue, green is FF and MMM, right? Else you have to see out unknown. Yep. So that's it about this problem. Yeah. Let's see. SSFF. What's the issue? Uh, what's the issue here? Constant. We don't need it. Come on. Do I have to save all of my files now? Did I write it in this? Come on, run it. Hmm, some kind of bug. Okay, this. I got it. I got it. So I just did a bit of reset with my. Uh, I think I will go for what was. I think it's called auto save, right? Save typing, right? Enable. Okay. Now I think it will save. Yep. So there's an empty bag. You are given Q queries. Process these queries in order and output the answer to each type 2 query. Okay. Type 1 query is as follows: 1x, put a ball with x set into the pick out the minimum integer from the bag and report that the integer and the answer the query is not the query is, I think we can put it in set. So what we can just say is it this must be Q, right? Yeah. So while uh, int t cnt if t is equal to 1, right? Then I have to take this x. We are not removing them, so I can always use a set. So st dot insert x. Else we can go over whatever the first value in the set is, which is I can get it like this. Cool. Uh, there's just one test case. Yep. Failed. Why? 112. Wait. Uh, list is input. Pick one ball of the minimum integer from the report that integer. The answer is present. Wait. You put 6, you put 7, then you put 1. Here, what you put? You put 5, 1, 1, 2, 2. You have to. Do you have to remove that ball? Okay, you have to remove it. So then I can go with map, right? Uh, let's call it MP, right? If so, I would go with MPX IMPX plus plus. Else, what I can say? Else int y is equal to MP dot begin dot first, and then I can say cout y handle MP y minus minus if MP y is equal to 0 MP dot erase y. Cool. My VS Code is acting a bit weird lately, so could be a bit of issues. It's really it really lags a lot. I have to uh, take care of it, which I will after this contest. Now let's go for the third problem. Yep. So there's a grid with 10 to the power n rows and 10 to the power n columns. Let ij denote the square at the ith row. I hope so it doesn't have any issues. Okay, ith row from the top and jth column on the left. Cool. There are n people on the grid. Initially, the ith person as the square RICI. The time starts at 0. Each person can do the following move at time 1, 2, 3, 4. N people. Initially, the person I is okay. Stay at current position or move to an 8 adjacent square. It is forbidden to leave the grid. Formally, let square ij be the current square and move on to the one of the square I that exists. So you can take like those 8 squares that you will have adjacent to yourself. You can move, right? Cool. Assume find the minimum possible time when the n people are at the same square. Okay. So these people will be uh, at these whatever these square would be. They will be at these squares and they need to meet at a place, right? So what does that mean? So the thing is that uh, if I have to move 4 in some direction, 5 in some direction, then I can reach in 5, right? I can reach in max of xy, right? I can reach in that time. That's it. Cool. No, but which point I should try for? That's the whole thing. So, mm, cool. I mean that would be interesting. Binary search, but binary search on which point? That's the whole thing. Well, uh, there must be some point from which everybody should have a distance of some some distance. Like their max xy should be. See, so what I can do, I will have x points of these and I will have y points of these, right? And what if I choose some x dash, y dash, what's going to happen basically is that I will take the difference, right? I will take the difference. So x point should be as close as that this difference actually becomes uh, basically this becomes less as I would want it to be, right? and y should also be that point that this difference actually becomes as less as I want it to be, right? If this is something that I can achieve, and after that, I think it would be how can I find this in linear time? This x coordinate. So basically, now problem is reduced to that you have some integers, let's say 1, 3, 5, 7, 8, 9. How can you find an integer such that this difference is actually uh, the minimum, right? So how can you find that? I think we can brute force and all, right? For this point, it would be the difference of all of these points. For this point, is it not same always? Let me think about it. So if you are on one, then it is gonna get added as uh, this will move two. No, basically every I want to reduce the maximum value of this difference as much as I can. That's the whole point, right? So the maximum value should be reduced as much as I can. So let's say I want to reduce the maximum difference till a point, right? So then, mm, well, see, if I want to reduce this maximum point, then this will give me a range, right? And mm, everybody will give me a range. Cool. And I will have a range for x, right? And if that's a valid range, I think that will be the minimum value of x which we can have, and I can get the maximum value like that. So basically, see 258, right? 258. So if I say the difference is the answer was 3, right? Cool. How it was 3? Some value must have been 3. So whatever you choose, uh, or is it that always the difference, the max difference that you would have? Uh, well, let's do binary search. I guess I would say let's do binary search. Or there must be something easier for this. I mean, I have uh, I have one solution in my mind, but I'm thinking if there's something easier, then we don't have to go for something so I mean so hard. That's it. So see, the thing is that you can go for basically you have some points and you want the minimum difference, right? Okay, so see, this will give the maximum difference and here it will give the maximum difference, right? Cool. So then you can take whatever you want, right? So in 258, whatever you choose, I think 3 will be the minimum, right? 3 will be the minimum. Cool. If 3 is the minimum difference that we're gonna have, yeah, I think I got it. Should I try points in between? Why would you try that? Because why not? Wait, well, maximum point, I think you always should stop at, ah, we don't even need to iterate on it, right? I got it. Intense CNN, I got it. Yeah, we have an easier solution. So it would be just the midpoint of them, right? So then 0 and r plus plus. So do one thing, sort all x and sort all y. There would be at least 2 points, right? No. If there's just 1 point, then I can reach in 0. So I would say uh, I would just say if n is equal to 1, see out 0 and then return 2. Now for 2, what we can do is uh, int xx would be uh, a x dot front plus x dot back divide by 2, and int yy would be y dot front uh, plus y dot back divide by 2. And by the way, I think I will go with ll because we are dealing with 9 years, so let's go with ll. And okay, what will be ll dx? Ll dx would be max of x dot back minus xx and xx minus x dot front, right? And ll dy would be max of y dot back minus yy and yy minus y dot front. Cool. So this is dx and dy, and now what I just have to see out the maximum of dx dy. Yep, I think this works. It does. At least it does on sample, so I have some hopes. But yeah, I think I have hopes from this. Yep, it did, I guess. Yeah. So it did. Yeah. I was going for a binary search where it wasn't needed at all. So, I mean, think easy sometimes, right? Because first I was going for binary search, then I was thinking about iterating on the array, and now at the end it was just about the midpoint of both maximum x and y coordinate and take the maximum distance. So always take 2 minutes to think something easy when the approach that you're thinking is actually going to take 20 to 30 minutes, right? Binary search would also work, but it is not needed. It is overkill. You're given n lowercase, you're given length n lowercase string, you're given n lowercase English strings s and t and m. Okay, n m pairs of integers li. Okay, got it. Perform the following operation 1 to m in order. Swap the lith through rith character of, wait, swap the lith through rith character of s, and I don't get it. Swap the lith through rith character of s and lith through rith character. Okay, so example, if 3 5, so you have to change c to e. I don't get it. It's phrased so bad. See, swap the lith through rith character. Swap the lith through rith characters. Okay, so from L to R, swap with L to R of this. Okay, that was phrased so bad. Basically, what you are trying to do is from 3 to take this sub-array, this C, D, E, and swap it with I, J, K. Cool. Find the string S after performing M operations. Now, these will be, of course, up to linear. These all will be linear. And each of S is a length of N. Okay. So some part of me is thinking about going character wise, right? So if I can somehow find that how many times this character was swapped, then okay, I can do it. If I'm saying 3 to 5, right? So that means this, and I'm saying 2 to 5. So that means 3 is being swapped twice. So this index is going to be preserved, and this can be done using a prefix sum. So for each I will have a count. If the swap count is even, then it will be the same value, or otherwise it will be odd. So for example, here 1 is being swapped once, so it will be L. 2 is being swapped once. No, is it being, yeah, it is being twice. 3 is being swapped twice, so again same. 4 is being swapped uh, twice, so again same. 5 being swapped twice, so again same. Cool. I think I got it. Uh, this one is much easier than, I would say, C. C was a bit tough. Maybe it's subjective, or maybe I'm missing some greedy here. But I will just go to code it, and because the code is not really big for this one, uh, and then just what you need to do is you have three queries, right? So while q minus minus, I need to create a prefix array. So let's call it vector int pf, and that would be of size, let's call it n plus 2, right? It doesn't matter. And strings, I'm gonna do one thing, that is to make string one based indexing. I prefer one based indexing on queries where they are one based indexing, right? So I go with okay, it's m. Cool. Now I'm gonna have int lr cn lr. So I'm gonna this prefix sum is actually depicting the count. So I'm gonna increase pfl by plus plus and pfr plus 1 minus minus, right? And then what I'm gonna do is for int I is equal to 1, I less than equal to ni plus plus pfi plus equals pfi minus 1. And now what I can just say, okay, for int I is equal to 1, I less than equal to n I plus plus. So if pfi and 1, so it is odd. If it is odd, then you should print ti, right? Else you should print si, right? Yep, and just end it. I think that's it. Let's see. Fast. Yep. I think this was much easier than C, of course, if I'm not missing something here, which I don't think so I am, because the swapping is happening element wise. And yep, I think it's an AC. Cool. So even after solving 4, my rank is not so good. So yeah, it's kind of it's maybe it's too easy. You're given an integer, you're given an n length integer sequence, right? The goal is to perform the following operation repeatedly so that every length L contiguous subarray of A, the sum is a multiplier of M. Okay, so for every subarray of length M, the sum should be a multiple of M. Basically, or you can say the modulo with M should be 0. Choose an integer I such that uh, and increase the value of I by 1, right? Find the minimum possible number of operations wait, find minimum number possible operations before achieving the goal. Okay, I don't get it. Perform the phone number. I think maybe it just means how many operations do you need. Okay, so what I can think of is that every length 3 array will have the same um, modulo, right? Basically. So what does that basically mean? That first three should have a modulo of 0. Then every this index they should have the same modulo m, right? I think that's all we need. So okay, I mean that is the condition that you require, right? But we are not told here to check if it is fine or not. So the condition that I have on array is that first of all this modulo must be uh, this modulo must be m0, right? the, like the sum of these three modulo m should be 0. Then these indexes should have same modulo, right? Cool. So now see, the thing is that if these have modulo equal to 0, right? So maybe you can touch them, right? It doesn't matter, you can touch them, you can still touch them. But let's see what are the values. All values are up to 500. Cool. M is up to 500. So see, what's gonna happen is that this place, and this place, and now they will keep iterating. They will have this. So I'm gonna brute force, right? I'm gonna brute force. Brute force is simple. I'm gonna use this will have this modulo, this will have this modulo, and this will have this modulo. But that's uh, five. Okay, I can brute force for two, I guess, right? What is 500 and 500? And for this, I think the modulo will be calculated accordingly, because that would be that. Because if these two modulos are fixed, then this should be something fixed. We cannot variate it, because if we variate all three, then maybe this sum will not be equal to what we need. So I will variate these two. There will be 2.5 E5 cases, and the size of survey is 500. So that's like uh, 500 cube. That's 1.25 E7, I guess. No, 8. And what is the time limit? Time limit is 2 seconds. I think it should work. So yeah, I think that seems like it to me. Mm, let's see. Where is the standing? Uh, so let's go with something like maybe I'm implementing this. So what are the parameters that we are having here? We will have nm and okay l. Yeah. Ah. So I just hallucinated. L is not gonna be 3, right? L can be up to n. So when L can be up to n, now you can't brute force. Yeah, you can't brute force. So basically what means is that there will be a size of L that should have the same modulo, right? Uh, with your M, they have the modulo 0, and then every two values that are at distance of L should have same modulo. Cool. So what do I can think of is that is it just not making them same modulo, but that's not only the only thing that we require. Well, see, uh, at max one value can be adjusted, right? So I can choose for one. I can choose for one that what would be the modulo of this position. Cool. I can choose. Yep. Now the thing is that no, no, not like that. See, there are two things. First of all, these groups. What what modulo should be make of these groups, right? And leader of each group basically, right? No, not leader of each group. Yeah, leader of each group, their sum of their modulo should be 0. Uh, so there are two optimization that are need to be done. So I need to choose modulo for each group, and then the sum must qualify to be 0. Now let's think one by one. So if I have some, let's say, some modulo that I choose for this group, right? Then uh, let's say I choose 5. So 3, this will take 2 operations, but the number is 7 and I'm choosing 5 and it's 6, then it would actually take 6 operations, right? So the thing is that I need to, mm, okay, I can try each modulo for each group. Yep, we can try that, but we cannot try if they are all compatible or not. That's the whole issue. So, okay, what we can do is we can try all optimal modulos for each group, right? This is the modulo, this is the most optimal that this group can have. And I think we can adjust one group. Like we can just adjust. No, but if you adjust, then everything would be adjusted. That's the whole thing. See, for each group, I can find out for what modulo, what will be their cost, right? For each modulo, I can find out their cost because these are distinct values. Cool. Now the thing is that we need, so we can list them like this. This is modulo, 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 right? So the thing is that now I will have these, let's say, how many groups? Like, let's say n groups only, right? So I can say dp taking first I groups. This is my mod and this is the minimum that I'm taking. I think this can work. This can work pretty well. So first of all, uh, summarize these values into groups. That's the one thing. How they would be summarized? They would be summarized based on their modulo, in the modulo of their index, right? So we will go with int uh, int n, then we have m, then we have l, and let's go with this. Now what we need to, first of all, we need to form groups, right? So I will call it com, and let's have m plus 1 size, doesn't matter. And I think l plus 1 would do because even l would do, right? So l would do. Cool. Now what I need to do is for int I is equal to 1, I less than uh, equal to L, right? I need to go till L because L will have, okay, yeah, L I plus plus, right? And here what I can say, int j is equal to I, and while j less than equal to n, then you put comp I dot push back a j. Cool. And then j plus equals L. So then we will have these components which we of course can debug. So let's see if we have nice components formed here. then we will move further. So, some issue, recurrent n plus 1, L, what's the issue? I mean, okay. Okay. We don't have to push it in I. Mm, okay, let's have L plus 1. Doesn't matter. Yeah, just push it in I. So now we have at 1 we have 4 3 2 or 2. Yeah, that's good. Here let me see for 4. So with 1 I will have 7 6. Cool. And 0 4 9 2. Yeah, component is good. Now we can move further. So for each component I have to find their for each value their answer, right? So that will be call it anything, maybe cost. That would be L plus 1 and L plus 1 and what? Vector int, I think M plus 1. Recently, let's call their cost 1E18. Well, the cost cannot be uh, much more. So this is fine. Now, this is the cost. Now we will iterate. I less than equal to L I plus plus, and we will now calculate cost for each modulo. Let's call it MD, or maybe let's just call it maybe K, and K goes from wait, what we are trying to calculate here? We are trying to calculate that each number will have certain modulo with M, right? That's what we are trying to calculate. So it can have from 0 to M. Okay. So now we need to find out cost. So we can go like for auto and X comp I, right? Cost I, cost I K plus equals, what would be the cost? First of all, I would say in MD is equal to X mod K, X mod M. So that will give me X mod M. Cool. That's one thing. Now, basically, I need to reach something, right? So I would say I want to reach K, right? So K minus MD plus M plus maybe plus M mod M, right? These many increases I would take to uh, like basically do this. So now this way I'm calculating cost for each group here. Now let me actually see how my cost is turning out to be. Okay. So I think cost, we are not taking a minimum or something, so we can start with 0. That was bad. So see, for 1, I think having a cost of 0. So we have 4 and 3, right? So 4 should take 1 value and 5 should take 2, so it's 3. I think it's working. Uh, okay, so this is good. Now we need to create DP. So DP would be on what would DP be on? Let me think about DP now. So DP is something like this, that you take first L groups and your mod is something like this. Yeah. So vector int dp l plus 1 and vector int mod can be up to m minus 1, but let's go for this, doesn't matter. So we will of course start from I is equal to, well, for 1 it would be just equal to cost, right? Yeah. So I less than equal to l I plus plus, and then go for each mod. K is equal to 0, k less than m, k plus plus. Cool. And so let's go with something like, so see, a total mod is becoming 3 here with 7, right? So, and currently I'm calculating mod for no, see, wait, there's something that I missed, I guess. Think about it. So this is the total mod is becoming this, right? So what mod you will take at this position? Uh, right now, see, right now our DP is just, so you can take any mod, right? So let's call it target mod. Target mod is becoming this. And for this place, I'm gonna take my current mod. Yeah, so there will be 3 loops. Would go up to, I think this would work. K less than n, k plus plus. Right. So see, what's happening? Maybe see, my mod is becoming 3. I'm using mod I'm using mod 5, and my mod is becoming 3 with 7. So what did I take from previous place? That means whatever x plus 5 mod 7 became 3. So what I can say is that 3 minus 5 mod 7. So I think that would be 5 only, right? So this is my uh, target. This is my k. Okay, target minus k. Cool. So, and here I'm actually calculating uh, dp I t. So int uh, p would be the previous one. Previous would be t minus k plus t minus k plus m plus m mod m. That's the previous that we will take from. So till previous point, this should be the mod, right? So dp here it should be 1e9. Now see, uh, uh, if I is equal to 1, then you can't take anything from the previous, right? So dp I and t, dp I t would be just cost I t, right? And you can do continue right here. We don't need to see that. Continue. Maybe yeah, continue would work. Now if so, now what we can say here is that dp I t uh, is equal to minimum of dp I t, and from here I'm taking cost I, and here I'm taking k, and from previous I minus 1 I'm taking p, right? So that's what I'm taking. Yep. And now what I can just what just I would need to print will be dp l 0, I guess, right? So I think this would be the code, and I don't know, maybe it works. Maybe it doesn't. We don't know. Okay. It passed for one but failed for one. Why does it fail? I mean, failing is a bit. Uh, Received output 9. Okay. Mm, mm, Let me see. First of all, I think dry running a case is much uh, harder situation. Well, see. We are grouping these numbers uh, on the basis of. So see, first of all, let me see component, and then I will see cost. Component is 6760492. Okay, then let me see cost now. Cost is something really important. So for making uh, I want to make 7 6. So for 0 it will take, wait wait with we're making it with 4, right? So for 7 it will take just 1, or for 8 it will take, for 6 it will just take 2, right? Wait, increase 7 to 8, that will give me a 0. With 4, uh, you can't use that much cost. Okay, this is 10, right? Okay, so for 10 I think, yeah, 7 is justified. For 1 you need to make uh 4 and 5. Yep. For 2, this would take 11 and 13, 15, 17, and then it became 9 for what? 6, right? Yeah, 6, you don't need to do anything, and for this you will take 9. For 7, however, 7, yeah, it took 1. For 8 it will take 3, 5, yeah. And for 0, for what? 3 3 6. That's a bit tricky. 3 3 6. Wait, 3 3 6. uh okay, that's not something that we are not using, so then cost is fine. Then what I'm basically saying is that, mm, wait, if I, uh-huh, what is inside this? Oh, here it should be. If I is equal to 1. Oh, come on. Yep, that's a very big mistake. I hope so it works. Yeah, it does. So, I mean, these small mistakes can uh, cost you some time. I had just, yep, I think because my approach was solid at most. I can't think of, like, this is just DP. I haven't done much, and I think it's just 500, the cube of 500, so it must pass. Yeah, cool. So, yep. Uh, Damn. I mean, it's good. Till E in 48 minutes is, it's good. It's good. So let's go for F.